Let's explore geometric measure theory. It is where the calculus of variations meets geometry. It deals with minimal surfaces and geometric optimization. Let's dive into an introduction to geometric measure theory, also known as GMT. It is a mathematical framework that combines measure theory with geometry to study shapes and their properties. It is about measuring geometric objects. Let us understand the connection to the calculus of variations. Geometric measure theory provides tools to solve optimization problems involving geometric shapes. The optimization goal is to minimize the integral of f of x, u, del u with respect to x, where we find shapes that minimize energy. Let's define minimal surfaces. A minimal surface is a surface that locally minimizes area among all surfaces with the same boundary. The mean curvature is zero everywhere on a minimal surface. It is a surface with a fixed boundary. Consider soap films as physical examples. Soap films are nature's way of solving minimal surface problems. Surface tension minimizes area automatically. It is where physics meets mathematics. Here is the mathematical formulation. The area functional, denoted as A of s, equals the double integral over s of ds, subject to the boundary of s equals gamma, which indicates a fixed boundary. The problem is to find the surface S that minimizes area among all surfaces with a given boundary gamma. The solution is that h equals 0, where h is the mean curvature. Let's see some key optimization problems. One is the plateau problem, which involves finding the minimal surface with a given boundary. Another is the isoperimetric problem, which seeks to maximize area with a fixed perimeter. It is all about finding optimal solutions. Let us explore key theorems and results. The Douglas-Radó theorem deals with the existence of minimal surfaces. Bernstein's theorem concerns entire minimal graphs in R3. Important key insights are regularity, where minimal surfaces are smooth, uniqueness under certain conditions, and stability, where local area minimizers exist. Now let's look at the real-world uses. Geometric measure theory has applications in architecture, such as membrane structures and tension surfaces. In physics, it is used in crystal growth and phase boundaries. In computer graphics, it helps with surface reconstruction and mesh optimization. It matters because it provides optimal design solutions, energy minimization, and natural optimization. Here is the summary of geometric measure theory. It bridges geometry and analysis. Minimal surfaces solve optimization problems. Nature provides physical examples. It has wide applications in science and engineering. Geometric measure theory reveals the mathematical beauty behind optimal shapes in nature, where calculus meets geometry to solve real-world problems. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.